So, thank you so much for the kind introduction. And my name is Tanatani and from Ochanomizu University. And today I walk you through my experiences and how they shaped me and reflections of research abroad, challenges, and in interdisciplinary collaboration. So before that, this is my CV, and I would like to introduce myself. I received my PhD from the Faculty of Pharmaceutical Sciences in the University of Tokyo back in 1998. And after that, I joined the Jeffrey Moore Group of the Department of Chemistry and Chemistry Engineering at the University of Illinois at Urbana-Champaign, where I stayed for about 1.5 years. So when I returned to Japan, I worked as a postdoctoral fellow in the Department of Engineering at Kanagawa University and conducting polymer research under Professor Yokozawa. And then I became an assistant professor at the University of Tokyo. And since 2006, I have been an associate professor at Ochanomizu University, where I became a fully fledged professor 2020. In 2009, so I began to collaborate with the Professor Ivan Huck, which I'm still doing to this day. And I'll talk about this collaboration later. When I was an undergraduate and graduate student in the University of Tokyo, I belonged to the Professor Shudo's lab in the Faculty of Pharmaceutical Sciences. I engaged in organic structural chemistry, and my research project was based on the findings from the medicinal chemistry research in Shudo's group. And Professor Shudo pioneered a new drug for leukemia that had almost no side effect compared to natural retinoic acid. And thanks to its aromatic amide structure. So the drug was approved and launched in 2005, and it is still in clinical use today. So during the course of the structure activity relationship studies, we found that alter the shape of the highly active compound AM80, so greatly reduced its biological potency. So through this work, I became fascinated by how small structural changes can dramatically alter the activity as a drug. And up to this point, so I have spent my entire educational career from my undergraduate studies through to my PhD study at the Faculty of Pharmaceutical Sciences, the University of Tokyo. I have never had the opportunity to study abroad, even for a short period. So meanwhile, the Professor Jeff Moore at the University of Illinois was conducting research in polymer and materials science. So research-wise, I have no ties to him. So, but I read his paper published in JACS. JACS is a very prominent journal in the chemistry, and I'm very interested in his work. So my PhD research on the oligoureas and oligoguanidines sparked my interest in the broader fields of artificial oligomers. So since I have no personal contact who could introduce me, so I decided to write directly to Jeff. So this is a very clear memory. I enclosed reprints of my papers and asking if he would accept me as a JSPS postdoctoral fellow, because the email at the time was not common. So about 2 weeks later, I received an email. So he sent me email. So I received email from him saying that he would be happy to host me. So when I received my PhD in 1998, the polymer has not yet become widespread. So this is the article, 1999 CMEM, Engineering News, used the phrase folding oligomers in its title. In those early days, the Professor Gelman and Jeff took the inspiration from the proteins and peptides. While the Professor Moore, Jeff Moore, drove his ideas from the conjugated polymers such as metaphenylene ethynylates, that is polymer. So having worked with aromatic compounds myself, I found Jeff's molecule design particularly appealing. So then these two researchers soon became the twin pioneers of the polymer field. Then Professor Gelman formally defined the term polymer. Yes, and the polymer. And in his 1998 paper, and Jeff provided the comprehensive more than 100-page review in 2001, and both of which remain the foundational works for the field today. So let me show you where the University of Illinois, where I studied abroad, is located in the United States. So Illinois is in the Midwest, right in the heart of North America. And the most famous city is in Illinois is by far Chicago, and on the shore of Lake Michigan, one of the Great Lakes. So Urbana-Champaign is about 4 to 5 hours by car from Chicago. So you just follow the Interstate Highway 57 south. And the scenery along the 57 is almost entirely cornfields and soybean fields. The Urbana-Champaign is a twin city with a population of about 200,000. And the temperature in summer reached around 30 degrees Celsius, but can drop as low as minus 30 degree in winter. So despite this, there is surprisingly little snow. I couldn't live without this down jacket in the January and February. So it was my first time living in such a cool climate, and that has really stuck with me. And I will now briefly run through my research with the Moore group. So the metaphenylene ethynylated oligomers form the cylindrical cavity of the oligomer, and which inspired us to consider that rod-like chiral guest better matches the cavity like this. The strength of binding depends on the length of the oligomer, and the total amount of the solvent exposed surface showed the minimum that predict a cavity length with the highest affinity for the rod-like gas. So we designed a cis 2,5-dimethyl piperazine for a rod-like chiral gas, and that can bind cavities of metaphenylene ethynylated oligomers and induced helical chirality proven by CD spectrum. Then interactions of rod-like gas with various sized oligomers show that the affinity constant K depended on the length of the oligomer and was highest around for 20 mar and 22 mar. Then we assume the dumbbell shaped molecule recognized and bind to the oligomers with greater precision regarding their length. So actually, the dumbbell-shaped guest also binds to the oligomers, and selectivity of the dumbbell-shaped guest was much higher than the lobe-like guest. And as you can see that I gained a lot in the States, and there are so many more, but I wanted to touch upon the ones shown in this slide. The first thing I gained was the deep understanding of experiment techniques and measurement for three-dimensional structures and their dynamic behavior in solution. So as a result, I was able to publish 2 papers as the first author. Also, by observing the writing review articles on polymers I told you in my previous slides, I gained a broad understanding of research and researchers in related fields. So later, I was lucky enough to be given the employment in a postdoctoral position in the laboratory of the Moore Group alumnus, Professor Yokozawa. I also first came across the research of Professor Ivan Hack, who would later become my collaborative research partner. So the kind of those around me cured my fear of English, helped me to make lifelong friends with whom I still keep in touch. The friends I made in the Moore Group are from the left to right, college professor and researcher in industry and professor of the University of Illinois at the Urbana-Champaign. And since this presentation is all about international collaboration, so in the spirit of this, so I wanted to show some people who I crossed paths with when I was abroad. So it is impossible to cover everything on this single slide. So I focused on the Jeff and Professor Gelman and listed those most closely related to me. So I will later collaborate with Ivan Hart himself, but so in his group, so Jan and Victor worked with him in Bordeaux, worked with me too. So Professor Yokozawa had conducted research at Moore Group before I did. And after returning to Japan, I began my research under him. So he is a polymer chemist and found a method for chain growth polycondensation of the alkylated polyparabenzoamide with very narrow polydispersities. So the polymer consists of a series of folded and methylated amide structure, which happened to me when I was studying in the University of Tokyo. So as such, I believe his polymer would form a helical structure in solution, which turned out to be the case. So through CD spectra, I found that it is showing the behavior of the dynamic helical polymer. And I don't think I would have been able to determine this if not for the experimental techniques I learned in Moore Group. So after that, I became an assistant professor in the University of Tokyo and then joined the Ochanomizu University as an associate professor. Then I have managed my own laboratory there. So subsequently, I initiated collaborative research with Ivan after meeting him in person. And as shown here, some students in my group have begun conducting research at Ivan's group. So since 2011, so 6 students in my group have joined Ivan's group in France or Germany. So he moved from France to Germany and have published the results of collaborative research in several international papers. And in early stages of our joint research, the student worked on research themes concerning the synthesis and the stereochemical annals of quinoline oligomer derivatives that were being advanced at Evans Group. And in recent collaborative research, we are conducting studies based on my chemistry related to the cis-type folded structure. So this is the research that the folded cis-type square amide was applied to the better sheet folders. The folded cis amide was applied to develop macrocycles quinoline oligoamide. So attempt to obtain the larger macrocycles by the condensation of helical oligoamides was unsuccessful. We came up with an idea to solve this solution. We introduced the folded cis amide bond into the linear helical quinoline oligomers to synthesize the larger macrocycles. We expected that the cis conformation of tertiary amide bonds would produce the kink and facilitate the formation of macrocycles. As the end substituent of the tertiary amide, the 2,4-dimethyl hereby referred as just DMB, was chosen since it can be easily removed after cyclization to afford the cyclic secondary oligoamides. This is an example for the synthesis of a cyclic heptamer. Under these conditions, we successfully obtained an 80% yield of a cyclic heptamer. And the removal of the DMB groups using TFA, the acid condition at room temperature afforded at 68% yield of the C7. So similarly, we had succeeded in the synthesis of these cyclic oligoamides and obtained their crystal structures. Among the cyclic oligoamides, cyclic pentamer and cyclic heptamer have the helical structure in the crystal structures. As we had expected, so we managed to obtain the various macrocycles all the way up to 14 Mar, utilizing the folded cis amide bond. So the most significant the outcome of the international exchange that expanded through the event was my participation in the Foldamer Symposium. So this is an international conference on the polymers, which have been held approximately every 2 years since 2010. I attended the 2013 meeting in Paris and the 2016, 18, 21 meetings in Boulder and gave an invited lecture at the 2023 meeting in Munich. So this year I attended the meeting in London, so as the only Japanese participant. So here are some photos from the 2023 Polymer Symposium in Munich. So this photo of the top of the center is with Professor Andy Hamilton, who appeared in my previous historical overview near the beginning of my presentation. So Tucson from Yonsei University is a friend from the Moore Group, and we went to a beer garden with his Korean Yonsei's colleague. So meeting Professor Nowick, he is also appeared in my previous historical slide. Being able to talk about the Jeff, so that was very memorable. So further, following my meeting with the Professor Jinpeng Kai, so we served as the guest editors on the special issue of OBC, which covered polymers. Yeah, this is happened this year. And here is a group photo from the London meeting I attended this year. So it was a very rewarding conference where I united with Ivan and Ivan's colleague Jan, Victor, Jules, and others, as well as the Professor Bingham, whom I befriended at the June workshop. So as the subcommittee of the Polymer Symposium, the workshop on aromatic polymers have been held since 2016. And while smaller in scale than the Polymer Symposium, it is an invited only conference. I was invited first to the meeting at Leeds University in UK in 2022. But unfortunately, due to the COVID-19 pandemic, so I had to decline in-person participation. So the photo above showed me participate online at the time. This is me. And from the 2025 meeting, I became an organizer, yes, and involved in selecting the invited researchers from around the world. This is a picture this year. And the final topic of my presentation, I would like to introduce the collaborative research project I recently began with Jeff. Yeah, I go back to talk about Jeff. So I have maintained contact with Jeff, and who was my host professor during my study abroad. And eventually last year, when I was visiting the University of Illinois to meet with Jeff in person, and we were able to start a new collaborative research project. So this is a picture about our discussion. And in this case, the key structure is folded aromatic amide chemistry. So already we could clarify the conformation-dependent electric property and publish it in the international paper with Jeff and Professor Schroeder in the University of Illinois. So after graduating from the graduate school, I have worked across the field of pharmaceutical science and engineering and science for about 30 years. So interacting with many foreign researchers and advancing my research and contributing the human resource development. And my laboratory is rather small, with just one faculty member, that is me, and fewer than the 10 students. However, I feel we have been able to produce research results thanks to my excellent students and numerous collaborators and international exchanges. So moving forward, I intend to expand my research further under the guidance of many professors, both domestically and internationally. So if my journey can encourage even one of you to take a step forward, then sharing my story today has truly been worthwhile. And this is a picture with Rachel and Professor Ben Ferrina. So this picture is just introduction of next speaker. Yeah. Thank you for your listening.